Hello, let's look for Divine Star, and the first thing I want to say in this video is that at Saturday at 1 p.m. Eastern Time, I'm doing the first live stream of me working on the engine. Some people have asked me to do that, so I'm just going to try it out, see how it goes. If you bother me enough about something, I might eventually do it. I was kind of hesitant about making a Discord, and then someone put in an issue to the GitHub repo to make a Discord, so that's why I did it. So I'm just trying to listen to what people want. But today, I want to talk about this new awesome queue system that I've developed that is basically a big answer to the question of how am I going to make this more performant on the server with many players compared to something like Minecraft. So obviously the first answer to that question is that the engine can use all cores of a computer, no problem. It uses something called constructor threads, and if you don't know what this is an Electron map. This is the debug console, and this drop down right now is all the threads that the engine is created and is using. These are web workers, which is just a thread. So I can access all these different threads, and I can look at the code that's in these threads. So I can look at the object that is for the engine in this thread, and it's Divine Voxel Engine constructor. So the constructor handles things like RGB updates or light updates, water flow updates, and building chunks when it's on the client side. So it's basically worked like this since the incarnation of the engine, and it's been slowly more and more using these threads like this. So this new system I have developed, and I basically had to write a whole separate library to handle multi-threading, and then integrate that library, and then build this abstraction on top of it in order to get this working. The library I wrote is called ThreadCom. Basically, it just handles communication between threads and setting up tasks on these threads and running queues of tasks on these different threads, and just trying to keep track of when these tasks or when these queue tasks finish. So the system that I created will create a separate queue for each of these kind of tasks per region. So what this means is that something that is 1,000 meters away or thousands of meters away will not affect what is in the current region. So these things will, if you run task in this one region, it's going to send these tasks to the different constructor threads on its own, and it's not going to block the thread from sending the task for the other region to those other threads and having them run. So all these things can happen in parallel and update in parallel. So that's basically, that's about 80% of the reason of having this engine or using this engine is because it's, it's truly multi-threaded. It can truly do stuff in parallel. So this really just takes things up to the next level. This is, as far as I understand, Minecraft does not work this way. Everything works kind of in a single thread, and I think some things run on, like light updates, they run in their own thread. But eventually I will have it where you can even generate the world in parallel. I did have a example of that working, but since I changed the way chunks are actually created and stored, I have to rework that entire thing. But I'm going to set that up where that won't even be render blocking on those threads that are actually doing that. So I just want to show this in action. So if we actually look currently, these are all the queues that are in the constructor threads that are synced to the world thread. So as you can see, we have the RGB update queue here, and it's for the main dimension, and it's at 000. So it's basically, this is the dimension, this is the region that it's in, and you can see that there's different regions. Eventually this will work for different dimensions also. So anything that happens And this queue is not going to affect what's happening in the other ones. And this is something that is created automatically. You do not have to worry about it. So you can say I already created one. But let me go around and just create the rest of them here. I can even just have some water flow around. That's just really fun to watch. Alright, so now if I go back and I have the printout again, you can see now we have 55 queues. It might seem a lot, but there's a lot of tasks going on. And in this space, since we're at the center of 0, 0, there's 4 different regions around us. So you can see all these were automatically created and everything was automatically updated. I can't exactly show you a very good them doing it, but I know from testing that it is doing that. Now I guess I just want to show you in the code how exactly that is working. So this is the actual function that gets run when you add a voxel, or this is not the break voxel function, but basically what happens is we get a state object and then we set an interval. So we start running these actions on an interval. So this stuff gets added to the call stack. So these actions get just queued up and running, and then we wait for this specific state object that is created to change state and to move on to the next one. So you can see we're, the pre-phase, and then the paint phase, and then in the post phase. So if we go to like pre-paint here, we call this set focus function. Now what this function does, I actually do this, is that it uses the task tool that I created and it sets the focus at the current dimension at XYZ. So this will automatically create the queue and then have it run that way. Now of course I have to call this function before running any task so to make sure that properly aligns, because these are all done with callbacks, as you can see. So nothing is blocking, nothing is using async await. It's all just continuous updating. I'm still working on making sure that everything is pretty much bug-free. There might be some problems that I haven't noticed yet, but otherwise everything works perfectly. I have not noticed any slowdown in terms of the engine actually working. So, and this eventually will be used for everything. A lot of the stuff I'm doing is leading up towards infinite world generation, and that can be extremely taxing on a computer if you let's say you're trying to do it in 2 different places at once. Let's say you have a multiplayer server. So this whole system is designed to try to mitigate that and try to use the computer's full processing power to do things. So yeah, and I guess the last thing we can just look at is I changed around this example world a bit. I just wrote a function to basically draw a circle. It's a pixel circle, so it's not exactly a perfect circle. Now these things have kind of a neat little roof on top of them. So yeah, if you have any questions about this, I guess just let me know. But I think this pretty much answers the question of what is this Voxel Engine going to do differently in terms of trying to handle many users on the server and doing updates and all of that. So yeah, I guess thank you for watching, and just a reminder that the live stream is going to be this Saturday at 1 p.m. Eastern time. I'm not necessarily sure what I'm going to be working on. I might be just working on trying to get the server example working again, or working on flow remove, so that might be cool. But yeah, so I guess thank you for watching, and I will see you in the next video.